Yes, ma'am. Please look at here. Are you able to see my screen? Is it visible?
Yes, ma'am.
Okay. Here is the data structure by the name called stack. We are going to see in detail today, as it follows a principle called LIFO, which I have discussed in the last class. LIFO means last in, first out. Most of the people will be naming it as first in, last out. Am I retrieving first in, last out? No, I'm doing last in, first out. This name reflect much better than the first in, last out name. So please don't tell anyone with the principle like it is first in, last out. No, that is not happening actually. It is happening with the principle of last in, first out. It was a fake statements and all. Don't go in other streams like that. Okay. Please follow. It has only one principle, that is last in, first out. Try to remember this LIFO. Okay. If in depth, I just want to go inside it. So it has some properties like it follows LIFO, and it has one index variable called top. From there only we can perform all the operations like inserting, deleting, or displaying. Suppose a stack is set overflow means it is full. Suppose a stack is set underflow means it is empty. Is it possible to add an element into the full stack? Already it is full. Is it the correct way to add an element into it? Can I add an element into the full? Then I should get a statement that its stack is overflow. That was the condition you need to verify. That means once top reaches the size -1 size, it is overflow. I can't add any more elements into the stack. Suppose I just want to delete an element from the stack, but stack was empty. Can I delete it? There is nothing in the stack, but I'm trying to delete it. Then such kind of situation is known as stack underflow. There is nothing in it, you can't retrieve anything or you can't delete anything. Right? Implementing of stack using arrays, there are certain functions. Please look at those functions first. Later on, we'll see the complete implementation of it, and it was implemented in java.util.star. Okay, from that package we are going to implement it. Before going to in-depth of stack implementation, here are some applications of stack. They are more than this, but in short I can give you this 2 to 3 applications. First application is reversing an array using the stack. That means array elements are 1, 2, 3, 4, 5. If I use the stack, the topmost element will be getting printed now. So 5, 4, 3, 2, 1. So it implements the reverse of an array. Then it is used for conversion expression and parameters count and recursion concept, conversion and postfix evaluation. These are the basic 5 applications what generally we use it. So for reversing an element, for reversing an elements in the array, and the expression evaluation, expression conversion. What is expression evaluation? What is expression conversion? All these points we'll see individually. We'll do examples depending upon them. Okay. Then in the recursion, we use stack concept. Okay. These are the applications of your stack. Please ask your son to please mute yourself, ma. Please don't give your phone to son. Actually, before going to this example, I just want to give one idea about expression. What is meant by an expression? It is a combination of operands and operator. It should retrieve some result back to you. Okay. In the expression, there are of 3 types: infix, prefix, and postfix. Infix means the operator will be in between the operands. Prefix means the operator will be in front of the operands. Postfix means the operator will be after the operand. Suppose if I take an example, I'm writing it. Please look at here. If I take an example, A plus B. This is an expression. Yes or no? Where is my operator? It is in between the operands 1 and operand 2. A and B in between, my operator plus was there. So this is what the infix expression. Now, when coming back to this, Prefix means first my operator should come, then the operands what it has to perform. So what is the operator over here? Plus. What are the operands? A, B. This is what the prefix expression. Now if I come back to this postfix, my operands should come first, then the operator. Getting my words? Did you understand what is infix, prefix and postfix? Shall we do one example about it? Yes? Am I clear?
Yes, ma'am. Ma'am,
Okay.
small doubt, ma'am. Actually, I don't have the Java subject in 6th sem.
Okay.
My subject is Internet Technologies using HTML file, ma'am.
Okay.
And another one is elective subject is web designing with MySQL.
Okay. So you don't have complete idea about Java?
Yes, ma'am. Actually, before section in 5th semester, we wrote about Java. But now we don't have these subjects which you are teaching.
But it's okay. You have some fundamentals of Java, no? I didn't get into the coding actually. I'll just come back to it and I'll explain each and every module in it.
Yes, ma'am, right. But when going to write the theoretical exam, we have to know the content, no, ma'am. That's why.
Content, you have to learn it, no? I will be explaining the theory and all.
Yeah, this is not similar to what you're telling, no, ma'am. That's why, that is my doubt.
This is not similar means it is there in the portion.
Yeah, yes, ma'am. But HTML file is different with this Java, no? That's why.
Obviously, you should learn it, no? My task is to teach this Java using Java. I'll teach with Java. It is your responsibility to learn it. I can't convert it into HTML, no?
Yeah, yes. And means, what's my doubt means, is only the program Java you will teach or else you will teach HTML also, ma'am?
No. According to my criteria and my syllabus, I'm having only through Java, not through HTML. Okay?
Okay, ma'am.
Right. Please take down one infix expression like this, A plus B into C plus D. Try to convert it into prefix. Here, conversion obviously starts with the precedence of the operators. Before going to the implementation of the conversion, we should know the precedence table. What is the precedence table? Parenthesis is having the highest priority. Parenthesis and square brackets. Then after we had division and multiplication. Same priority. Then the addition subtraction. If you get the power symbol like cap and all. If you get that power symbol cap. If you get this symbol. Are you able to see this symbol? Power symbol. If you get this power symbol. If you get this power symbol. Are you able to see it? Yes, ma? No one was there in the class? Yes, if you are able to perform this conversion of expression, you should know the precedence table. First in the precedence table, we are having parenthesis, then followed with the power or exponential or any other special operators, then followed with the division, multiplication, addition, subtraction are having the least priority. And the conversion will start from the left to right of your input string. So if I take this input example like this, so what is the first symbol? A. If it is an operand, remember here, if it is an operand, please write like this only. If it is an operator, please check with the precedence of it. What is the highest priority it is having? Multiplication. Yes or no? So how we are going to write this one? First, we need to write A, B into C. So, BC asterisk. First, you need to write this. Why are you putting the message in the chat, ma? Priyanka? If you want to message her individually. Don't put the message, ma. Okay? First, highest priority will be given for the multiplication. So here B into C will be getting multiplied first. So BC asterisk. Prefix no, I should add it in the front. Then from left to right, I am having plus symbols both at the side. So first I'll add B into C with the A. So plus A, B into C. Then after plus D. This you need to perform stepwise. If you are well known, you can do it in a single step. If you are having any confusion, please go stepwise. First, which is having the highest priority, take that piece of operands and operator, perform the expression conversion. So here B into C, prefix asterisk, followed with A into B, A plus B into C. This is one operand and this is another operand. Operand 1, operand 2. Then plus symbol, operator should come front. Then after, what is your operand 1? A plus B into C is your operand 1. D is another operand 2. So plus symbol, then all this operand 1 followed with operand 2. This is what the prefix conversion. Now coming back to the postfix expression, I already told you highest priority will be given the first priority. So B into C will be multiplied first. Then A should get added with it. A, B, C asterisk plus. Then to that D result should get added. Operand 1 is up till there. Then operand 2 is D. Then the addition symbol. Are you able to follow with this example? Yes. Am I audible, guys? Yes, ma? Why only 3 members in the class? May I know the reason? Yes, ma. Someone please respond. Neelofar or Baru? Why the strength is so less, ma? Only 3 students are there. Can I continue? Yes, I am continuing it, ma. So in order to convert one expression to other type, we need to remember only 2 points. What are those 2 points? Means based upon the priority, we'll keep on converting it. Either we are performing the prefix or infix, we should concentrate upon it. Okay. This is what the conversion. Basic stack program using the array. Before going in depth to it, what are the operations of the stack? Push, pop, and display, and the top element, and is empty or not, right? So, and retrieves the size also. These are the basic functions what will implement it in the stack. So, first I am creating an interface for that. In the interface, I am writing certain function declarations was there. Now I am defining each and every function over here. So, initially what did I do? The size as 100. And I used a generic array to implement it. Then the top initially I took it as minus. So I'm using the constructor over here by the name stack, as I've given the class name as stack. Then I'm using this particular object and I'm assigning the memory for it by using the default. Then what is the first method? Size. So it always returns the top plus 1. Means why it is returning top plus 1 means initially top is minus 1. So minus 1 will get it to 0. 0 to some 4 means it is having 5 elements. So I should always take top plus 1. Boolean is empty. Is it empty or not? I am verifying. Wait a second, it will come. Is empty means return top equal to minus 1. That means there is nothing in the stack. Push. Push means what we will be doing? We have to increment the top first, then add that particular element into that particular index. Got it? First increment the top, then add whatever the element you want to add it. Suppose it already reaches the size means it will raise an exception that stack is full. Then top, that means it returns the topmost element. Pop, it will pop the topmost element and it will decrement the top. Okay. So in the main, we are using push function 4 times. So first, what did I push? 23, 24, 25, 26. Then what could be the size? How many elements are there in the stack now? 4 elements. What are the items in it? I just want to print it from the top to the bottom, no? So the items will be getting printed as 26, 25, 24, 23. Okay? From the reverse, it should get printed. Did you understand this? Yes. Yes, ma. Yes, did you understand? Can I go with the next one? This reverse of an array elements, ma, please you just try by your own self. Okay? Please look at this example code. Infix to postfix conversion. Yeah, am I audible actually? Infix to postfix conversion. First, I already told you that we need to make a precedence for it. So please write down the precedence function first. For each operator, what you want to give the value. Highest precedent means highest value should be there. 3, 2, 1. For addition subtraction, this is the least, no? So I'm giving the value 1. Suppose some exception operator like $ something is given, it should return 1. Right? So based upon the length, if it is an operator, then I need to pop the topmost element. Suppose if it is an operator, please push it back into the stack, depending upon the precedence of it. I'll discuss this in detail while we are executing the programs, ma. But meanwhile, you remember the method. What is that method you are having? If it is an operand, please keep it on the output screen. If it is an operator, please push that into the stack. Until what you need to do? Until you find the topmost element is having the highest priority than the entered operator. Suppose the entered operator is left parenthesis means until you encounter the right parenthesis, you keep on pushing the elements into the stack. This is what the method actually performed in the infix to postfix conversion. Okay? Did you understand with this? Can I go with the next one? Yes, ma. These are some various functions or methods what you need to learn from it. Yes. Before going to this topic, I just want to revise it once again. What is that means? Stack is a linear data structure which will be based upon the principal LIFO. What are its operations means? Push, pop, display, top, size and all. So among them, what are the applications of it means? It is used to convert from one expression to another expression. It is used to evaluate an expression. It is used to balancing of the parentheses and recursive function call. And it is used to implement the graph concept like DFS. So these are the different applications of your stack. And among them, the one of the applications what we are seeing means infix to postfix conversion. So in that conversion, if the scanned symbol or the input symbol is an operand, operand means please write it on the output screen. Suppose the input symbol is an operator, then please push that into the stack Before pushing, please verify one condition that stack topmost element is having the highest priority or not. If stack is having the highest priority, please pop that and push this back into the stack. Suppose the input symbol is left parenthesis means keep on popping the elements from the stack until you encounter the right parenthesis. This is what the implementation of your stack conversion from infix to postfix. Right? Did you get it, ma? Yes. One more data structure, that is list data structure. List means it is like your array, but dynamically I want to grow it and shrink it. No, dynamically I just want to increase its size and I just want to remove it depending upon my requirement. So such kind of operations can be implemented by using this dynamic memory allocation by using this linked list. Before going in detail to it, let me give you the operations what we can perform upon a list. I can traverse. Traverse means what? Printing each and every element in the list. Size returns the number of elements in the list. Is empty returns whether the list is empty or not. Boolean value. The list is empty means it will return true. The list is not empty means it returns false. Get I means it returns the value at the particular index I. If that I is not in the range of your size, it returns an error condition. Set I at E, that means set some value E at the index I. Right. So these are the functions. Add means adding, that means inserting an element into the list at the particular index. Removing means deleting. So with the vector, it is like implementing using arrays only by using the static memory. We don't implement it with using the vector. We use it with the help of the dynamic linked list method we will be using. That means dynamic memory allocation we will be using in order to implement this linked list. So before going in detail of this linked list, there are 4 different types of linked list. First linked list is single linked list. Single linked list means it is a linked list where each element will be having a link with the next element. That means each element will be having a 2 parts. One part is the data part, other part is the link part, or the next node address it will be storing. So sequentially, did you see the train? No, from one coach to another coach, there will be a link in between them. The same way, the linked list will be there. But here single linked list means I can go from A to B, B to C, D to D. But I can't come back from D to C, C to B, C to A. Reverse is not possible here. And remember one thing, first node is always indicated with the head and the last node is always indicated with the last, and last node next part will be null. This is what the single linked list. It is a collection of nodes where each node contains 2 parts, data part and next part. Data part means storing the value part. Next part will store the address of the next node. So doubly linked list means each node will contain 3 parts. What are those 3 parts? Previous part, next part, and the data part. Data part always stores the address of it. Next part will be storing the address of the next node. Previous part will be storing the before node address. So doubly linked list means by the name itself, it suggests that it can travel in both the directions. I can go forward, I can come back. So address space will be more. That means memory wastage will be there to some extent, but easy way communication is possible by this linked list, right? First node is indicated as head and the last node is indicated as the last or tail. Depending upon the user interest, he will be naming either head or last, right? And remember the note point that there will be no previous pointer to the starting node. That is the first node. How can it will be having a previous node? So it will be null. And last node next pointer, that is the last node. That indicates that no other value will be there next to it. So how come that will be storing some value? So it will be null. So previous node in the head and the next node in the last will be null for the doubly linked list. One more type is circular doubly linked list. Circular doubly linked list. What is the meaning of this circular doubly linked list? Means last node will be pointing again back to the first node. That means last node next pointer will be pointing to the head, and head previous node will be pointing to the last. Previously in the doubly linked list, we are seeing that first node previous pointer is null and the last node next pointer is null. So we are replacing it with the head and last node addresses. So that will become a closed loop. That is what circular doubly linked list. Did you understand with this? Yes? Did you understand, ma? Yes? Can I go further? Yes, no one is responding. Are you there in the class? Yes. Are you comfortable with this definitions of the linked list, circular, doubly circular list? So here is the implementation of your linked list. Suppose here we need to concentrate upon two things. What are its, how we are inserting it, what is the constructor is taking place, how it is getting implemented. Those all things we need to keep in mind. So before going in depth to this implementation by using the array, we don't concentrate upon this much. I'll be just showing you the another way. That is what implementing by using the memory allocation. Wait a second. This is just like implementing using arrays only. Yes. Not. I'll just show you 1 second. Give me 1 second. Yeah. Suppose if I want to add an element into the linked list, you should use a dynamic memory allocation method. That is, dynamically it should create the memory for me by using the new keyword. Then the memory will be allotted to a node. And what that node is containing? Data part and the next part, that is your storing address. Initially, your null will be, sorry, your head will be null and your tail will be null because it is not created first. Initially, they are null. So now you want to create them. By using new node name, I am creating it. So whatever the previous field and the next field, you are making it as null. And the value which you want to put inside, you are just adding it into head pointing data. Into that you want to add the value. See, head pointing data. Into that you are just adding the value, right? Like this we'll continue the operations. Do you want to repeat it every time? Yes, I just want to repeat it. So I will be doing do while loop, or I'll be calling this particular function as many times I was required. So those many nodes it will be creating for me. Right? So what is the next function to get the size? It returns the size. Get inserted a particular node. I just want to give a particular position and I have to move to that particular position first. Whether that position is the starting element means I'll be just changing the head value. Suppose it is not the starting position means I'll be just moving it to the particular position and then placing it. Right? Then removing the node at a particular position. That means deleting the node. Deleting the node means Here deleting it permanently. By using new node, I'm creating it now. I'll be using delete keyword. Right? So until I reach that particular position, I'll keep on traveling from there. If head is null, I'll just tell that it is not created. And if current, that is whatever the node is not null, then I'll be just moving it to the next node. Right. This is what the implementation of the doubly linked list, which we will be seeing in our coming up lab and all. Okay. Are you comfortable with this? Can I go with the next one? Here are the display function and all. Its implementation, I'll be discussing it in the lab. Okay. Please look at the next data structure, that is queue. Before going in depth to this queue, I just want to revise the one's linked list. Linked list means it is a collection of nodes where each node will be connected with the other node by using the link. And each node contains two parts, data part and the next part. And there are three types of linked list, single linked list, four types of linked list, single linked list, circular linked list, doubly linked list, circular doubly linked list. Depending upon the situation, you will be using either of the things. The implementation of each and every data structure, I'll be discussing it in the lab completely. Okay, right. What is the next data structure? Queue. It is a linear data structure. It follows the principle like first in, first out. That means whatever the, generally you will be standing in a queue in order to fetch anything. Best example, if I want to give you, like if you are in a laddu counter. Whenever we visit a temple, we would like to eat some prasad, no? So when you stand it in a laddu counter, the one who stands first, he will be served with the laddu first or not? Yes. So that is what the principle of first in, first out. That is what the behind of your queue. Right. In this queue, we can perform what are the operations you can perform on any data structure? Insertion, deletion, traversal, then size, is empty or not. So all those operations I can perform upon this queue also. And in the stack, what is the variable? Top. Whereas in the queue, what are the two variables we are having? Front and rear. Front end, we will be start deleting. From the rear end, we'll keep on adding the elements. Rear ante venkatal nunche kadandi janal add avtaru. Yes or no? From the back end only, the elements will get added, right? From front, we are going to come back. That means this particular queue is having both the ends, front and rear. Where from the front end, we will be coming out from the queue. From rear, we are getting inserted. So insertion will be taking place from the front end and deletion will be taking place from the rear end. Deletion, small mistake, ma. Please try to change it. From the front end, the deletion and display will be taking place. From the rear end, only insertion is possible. Right? These are the two different pointers or variables which are used to perform the operations of your queue. And initially, how you have taken top as -1, here front rear are also -1. NQ means insert an element into the queue. DQ means deleting an element from the queue. Deleting means what? Just incrementing the front. See, here you go with the example. From the front end, it will go out. From the rear end, the insertion will be done. Right. There are different types of queues, ma. Yes? Anyone wants to talk? Yes, who is that? Can you please unmute yourself if you don't want to talk? Yes. There are different types of queues, ma. Circular queue, DQ, priority queue. Circular queue means just now we have seen that both the ends are open. Try to get turned into a circle. That means both the front and rear ends will be getting to one particular node. Such kind of node Q is known as your circular Q. Double-ended Q, that is DQ, means from both the ends I can insert and delete the values. That is what DQ. That is double-ended Q. From both the ends I can perform the insertion and deletion. Yes. Are you comfortable with the definition of the Q? Yes. Am I audible? Here is the program to implement the Q. First, I have declared the size of the Q as 5. Then, front and rear values, initially I am using a constructor. My string constructor is a constructor. And I am taking front and rear values as -1. Then boolean is empty. Is empty means what? If nothing is there, it should return true. If something is there, it should return false. Is empty function means if it is empty, it should return true. So that is what it is written over here. Is full means once the front is pointing to 0 and rear is pointing to size -1. That means rear is pointing to the last element in the Q and front is pointing to the 0th location, then it is full. All the elements are filled in the Q. If not, it should return false. That means it would be empty. Then get size means it returns the size. How many number of elements are there? That means it returns the rear value. NQ means inserting. If it is full, I can insert it? No. Else what I have to do? I should increment the front first. If the front is -1. Initially, there is nothing inserted means I should take f equal to 0 also. And then please increment the rear first. Then whatever the value you want to add it, please add at the index of the rear. That means item of rear is equal to your element. Then print that so-and-so element is inserted successfully. So this is what the statement will be performing when you are inserting an element into the Q. What you are doing? You are incrementing the front and you are incrementing the rear. Then you are adding the element in the rear position. This is what the inserting an element into the Q. For the first case, suppose if front is not -1, just you will increment the rear and you will add the element at the rear position. Then deletion. If it is empty, I can delete it? No. If it is not empty, what I have to do? What is the element there in the front position? I already told you that deletion should start from the front. Deletion and display. Until what I have to delete it? Until I found no more elements to be inserted in it. So both the values are at the same position. Front greater than or equal to 0. Rear. Then in this situation that there is only one element in the Q. So after deleting, both should get to -1. Both should get to the -1. Else, if this is not the situation that it doesn't contain only one value, it contains more than one value, you need to increment only the front. You need to increment only the front. That means obviously it returns the front position. Front position, whatever the element you have deleted, that it will be displaying for you. So by using the void transfer, that is to display the elements. If it is empty, I can't display it. So by using the else function, from front to rear, I'll keep on displaying the elements. From front to rear, I'll be keep on displaying the elements. What are the functions you have learned? First, you have learned the insert, delete, display. In the insert, what is the condition you have verified? If a front equal to -1 means, please increment the front, then please increment the rear and then add the element into your rear index of the item list. In the deletion, first check whether front equal to 0. That means your Q is empty. There is no element to be deleted. That is one situation. Then the other situation that if it has only one element, that means your friend equal to rare. In certain situations it happens. So if friend is equal to rare means both friend and rare should become -1. Else, if that is not the situation, that means you have more than one element. Then what you need to do, please increment only the friend and just display whatever the element has been deleted. Suppose you want to display the elements from the queue. What you are doing? You are want to print it from the friend to the array. So assign I value with the friend. Repeat the loop until it is less than or equal to the array. Then try to display all the values from the queue. This is what the main motto of it. So by using the main function, we are invoking all the methods and we are declaring the size for it. Depending upon it, you will be fetching each and every execution of the part. So here, by using, what is my file name? mystringsq.java. I have compiled it. Then I am running it. Now queue is empty initially. Then I just want to add one string. What is that string? AB. I just want to add one more string, that is AC. One more string, that is AD, AE, AF. Once it reaches the size of your queue. Then I just want to display them. I have displayed it. What is the value of your array? 4. I just want to delete it. First element it will be deleting. So that is AB. Then after it continues like this. This is what queue implementation using arrays. Are you comfortable with this? Can I go with the next one? Yes? Can I go with the next one? That is by using the linker list. Linker list means first we should take a node class. In that we had two parts, data part and the next part. By using the constructor, I'll be writing front and rear as null. And by using the boolean isEmpty, isDq, enqueue, that is inserting, and traverse. And from the main function, if I want to add it, I'm adding 6, 3, 99, 56, 43, 89, 77, 32, 232. All this I've inserted. How I'll be getting 6, 3 and all only. How I have inserted? The same way it will be giving me. Suppose I just want to remove it. So what is the element got removed first? 6. Later on, if I again press the delete function, then again it will be removing 3. Like that, it depends on it. So based upon the operations, it will be performing for you. Are you comfortable with this queue? Queue data structure? Yes? Yes, ma, someone should respond. Or shall I repeat anything? Yes? From your side, any requirement? You need to write the code for the circular queue, DQ and normal queue by using the linker list. Coding is very, very important, ma. Yes. These are the functions. Yes, are you comfortable? Can I go with the next one? Here are some of the examples what you need to do for you. Write a program to implement the queue using arrays, taking the input type as integer. Try it with the char data type also, if possible. Whatever I have discussed with this integer, please try to change it with the character data type. Okay? Yes, ma, are you getting anything? Yes, no one is answering. Are you listening? Yes. Yes, ma. Can I continue with the next one? Can I continue with the next one? Yes, so far whatever I thought, I'll just revise this once. First topic is for your data structure is in your data structure concept, we are having mathematical review and analysis of it, asymptotic analysis. First, mathematical means first you have learned about algorithm types and its properties, how to write an algorithm. Performance analysis is very, very important. That is the space complexity, time complexity. Under that, we have seen two examples for each, followed with the mathematical foundation. We have seen the asymptotic notation. Asymptotic notation means the representation of your time complexity. It can be done in three ways, big O, omega, and theta. Depending upon the minimum, maximum, and within the range of your values, we'll keep on analyzing the time complexity of it. If you want to find the maximum limit of your time taken for a code, you will be taking the big O notation. Suppose if you want to take the minimum time complexity means you are going to take the omega. Suppose if you want to take the range of it, it is the theta. That means minimum, maximum. Okay, this is what the asymptotic analysis. Followed with the stack data structure we have started. So stack is a linear data structure. It follows the principle LIFO and it has the operations. On any data structure you take, what are the operations we can perform means we have to create the data structure. That is like allocating the memory for it. Operations what we can perform means insert, delete, display, size, empty. Insert means adding an element into it. Display means viewing all the elements. That means printing all the elements in the data structure. Remove means deleting the element from the data structure. Only one element, not a bulk element. Empty means is empty or not. Full means is the data structure is full or not. These are the different functions what we can perform upon any kind of data structure. When coming back to stack, we are having a principle called LIFO. And what are the operations we can perform means push, pop, display, is empty, is full, right? And what are its applications means converting the expression from one type to another type, evaluation of the expression, recursive function call, then parenthesis balancing, balanced parenthesis or not. Then in the DFS, we'll be using the stack, right? Then coming to the linked list. Linked list is a collection of nodes where each node will contain two parts, data part and the link part. And by using this, we can create as many nodes as by using the dynamic memory allocation methods, right? Then different types of linked list are there. Single linked list, circular linked list, doubly linked list, circular doubly linked list. In the single linked list, first node is named as the head and the last node is named as the tail. And you know that each node contains two parts, data part and the next part. Data part is the part which is storing the value which you have inserted into the linked list. Link part or the next part will be storing the address of the next node, right? And in the linked list, first node will be linked to the second, second will be third, third will be fourth. And the fourth node, if it is the last node, the next part should be none because that indicates the end of your list, right? Then the circular linked list means circle. It should make a circle now. So the last node next pointer instead of null, it should point to the first node. So it should be replaced with the head node address. Suppose if you want to go with the next one, that means the disadvantage of single linked list is I can only travel with the one way. I can't travel in the both the directions. So to overcome that, we have introduced a next type of linked list, that is doubly linked list. And a doubly linked list, each node will contain three parts, previous part, data part, and the next part. Previous part will be storing the previous node address. Data part will be storing the value which you have inserted into the list. Next part will be storing the next node address. So here in the list, for the first node, previous part will be null. That is for the head node, the previous part will be null. And the last node, tail part will be null. because last node, next part will be, that is the tail node, next part will be null, because that is the last node where is the link for it to store the next value. So in the doubly linked list, first node, that is the head node, previous link will be null, and the last node or the tail node, next pointer will be null, right? And coming to the next one, that is circular doubly linked list. Circular means what? Last should connect to first and first should connect to last. So how can I connect it? First node, that is the head node, previous link, I will be storing it with the tail address. Then tail node, next pointer, I will be storing it with the first. So it made it as a circle. This is what the circular doubly linked list. And the implementation means what all the operations we can perform upon any data structure, the same way we can implement here also. Then the next data structure is queue. Queue data structure means it is a linear data structure. It follows a principle like first in, first out. Just ticket booking counter is the best example for your queue. And what are the variables under it means front and rear. Both are -1 initially. Operations are insert, delete, display. We can perform mostly. So in order to insert an element into it, we need to check whether the front is -1 or not. If front is -1, please increment it. Every time you need to insert the element at the rear end only. Increment the rear, whatever the value you want to add it, please add the rear index of the array. Then please that element will be getting added into the queue. Right. This is what inserted. Deletion means, suppose if you want to remove an element from the queue, what we'll be doing? We'll be just incrementing it from the front. That will be deleting the starting element. Suppose I just want to display the elements from the queue. I should start it from the front and I should repeat the process until the rear. So from front equal to rear, from I equal to front, I should repeat the I until I reach the rear. I'll keep on printing the elements in the array. Right. This is what the queue implementation. Are you comfortable up till here? Yes, ma'am. Are you comfortable? By this, we have finished the first unit and then we have done with the second unit, first topic. Tomorrow, I'm going to continue with the trees and graphs. Is it clear for you? Yes? Next topic is trees and graphs, ma'am. Shall I continue it on the tomorrow's class? Can I continue it on tomorrow? Yes. One of you please respond, ma. Are you listening to me? Am I audible? I am not audible. Yes, Neelafar. Are you comfortable?
Yes.
Okay. This is the class for today. Right. You can leave from the class, ma.
Okay.